Welcome to a lesson with Dr. Powell. Let's take a look at an application problem for using quadratic functions that have a max or a min. For instance, let's suppose that we have a situation like this. We're trying to build something, maybe some pens or something where we have some fencing materials. Suppose this is X length, and then this is a W, and suppose it's the same W. And we want to construct this in such a way to maximize the area contained, but we have a restraint. We only have so much fencing to use, and we want to use all of it. So suppose we have something like 100 feet of fencing. Then what should X and W be to maximize the area involved? That's the question. So we're trying to maximize area. Keep that in mind. Trying to maximize area. Now, normally when we have a vertex of a parabola that's down where we have a maximum, we're maximizing y value. So the y value actually represents whatever in the situation we're trying to maximize. So let's let area be a y value. So let's write y equals area. So now we just need to write down a formula for the area that we desire. So remember, the area of a rectangle is length times width. So we think the area of this whole thing would be x times, looks like w plus w, 2w. So x times 2w, and this is what we're after. But what we'd like is we'd like a formula for y that only has x's in it, not another variable like w. So somehow we need to change that w to be written in terms of x. That's where we use our restraint, right here. 100 feet is the total amount of fencing. So, well, let's think about what that means. That means that x plus x plus x plus w plus w plus w plus w is equal to 100. So we could write that out. 4w plus 3x is equal to 100. Now, if we want to write w in terms of x, this is what we use. We need to solve for w here so that we can take it and replace w over here with it. It'll be in terms of x. So we can write 4w is equal to 100 minus 3x. Then we can divide both sides by 4. 100 minus 3x divided by 4. That's what w is. We can replace this w with it. So we get y is equal to x times 2 times 100 minus 3x all over 4. Now maybe we can simplify a little bit. This 2 is 1 and 2. Okay, let's keep working with this. So we see how we have this 1/2. Let's just kind of move that 1/2 out to the front. And then we have an x multiplied by 100 minus 3x, and that's equal to y. Let's make sure we understand why this works. See this 1/2, the 1/2, I just moved it because multiplication is commutative, meaning you can rearrange the order. So I put the 1/2 out front multiplied. Then I have x times, and then I have quantity 100 minus 3x. Okay, so we can distribute this 1/2 x in here. So if we distribute to this and to that, distributing to the 100 becomes 50x. Distributing it to the negative 3x, it becomes negative 3/2 x squared. And that's what y is equal to. Okay, so we came up with a quadratic function that we can find a maximum of. Look how the x squared has a negative coefficient, which means it indeed will be a maximum. So let's work through that and see what we can come up with. Okay, so that was 100. Okay, so let's rearrange it. Y is equal to negative 3/2 x squared. plus 50x. I'm going to factor out a -3/2. So we get x squared. Okay, and then 50, how do you work with that? Well, if you want, if it's easier for you to think about -3/2 as being 1.5 or 1.5. And then what we have over here is we simply have 50 divided by -1.5. That's what it is when we factor it out. And you can check it, just double check. If you multiply it in, that looks good, and multiply this to this will cancel left with 50. Yes, it looks good. Okay, so we have something like this. Now we replace this bit right here with, and maybe I'll just erase this so we can just kind of show our work here as we go. All right, this bit with x, and then we need to take 1/2 of that. So in taking 1/2 of that, we end up getting 16.6 repeating. So we take 1/2 of this coefficient, put it here, but remember when we do that, that's just x, and then that with the sign associated with the square. And then we subtract this quantity squared, which is 277.7 repeating. Okay, so, and then of course we have this outside still, -1.5. Okay, so we have just completed the square, and okay, we know that this is a minus right here. Oh, but we also have to remember, yes, when we complete the square, we did it inside of a bracket, right? So we had a bracket here, the -1.5 was outside the bracket, and then we replaced this inside the bracket as a square, and then we had a minus this. Now this is important to remember because we were looking for a maximum and one maximum area, so we want a negative value. So this guy right here will distribute to both parts, and when it distributes to here, then we'll get our positive value. And we end up getting right here for that value, 416, positive 416.6 repeating. See how it's positive, and that's the maximum. And it happens when the x value is 16.6 repeating. So when x is equal to 16.6 repeating, then this is the maximum right here, and that's the maximum area. If we wanted to know what the dimensions were, we know what x is. Could we figure out what w is? Well, we could, even just from this idea right here. We know the area is 416.6 repeating, that's the y value, and that's equal to 16.6 repeating multiplied by 2w. So in here, we could solve for w, and we end up getting getting 12.5 for w. So when we divide by 2 and divide by 16.6 repeating, we get w is equal to 12.5. So we have just found the dimensions. W is 12.5 and x is equal to 16.6 repeating that maximize the area, and the maximum area is right here, 416.6 repeating. Thanks for watching.